Okay, so to balance the equation, we're going to write all the symbols for all the elements in these formulas on this side of the equation. We have H's and P's for phosphorus, H's for hydrogens, O's for oxygen, and K for potassium. And those should be the same elements we have on the other side too. That's how you balance the equation. So then we're going to count the number of elements we have on both sides. Right now I have 3 hydrogens here, but 1 over here. So that's a total of 4 hydrogens right now. I've got 1 phosphorus on this side of the arrow, and I've got 4 oxygens here, but 1 over here, so I've got 5 oxygens. And I've got 1 potassium. On the other side of the equation, I've got 2 hydrogens here. I've got 1 phosphorus. I've got an oxygen here and 4 here, so 5 oxygens. And I've got 3 potassiums. Okay, what I need to do is to get all these numbers to be the same for each element. We always save oxygen for last. We try to balance it at the very last, and we balance hydrogen next to last. So the place to start then is with potassium.
That's where I messed up. I put 3K instead of K3.
So if I've got K3 here, that means I've got 3 potassiums. Over here, I will have 3K. That's how I'm going to get 3 potassiums. But by putting that 3 here, it multiplies everything in this formula. So now I have 3 potassiums, but I've changed the number of oxygens. So I've got to count all the oxygens. I've got 4 oxygens here, plus 3 oxygens here. 3 times 1 is 3. So right now on this side of the arrow, I've got 7 oxygens. Alright, I've also changed the number of hydrogens. I've got 3 hydrogens here, and I've got 3 times 1 or 3 hydrogens here. That's 6 hydrogens. Alright, so the potassiums are balanced, phosphorus is balanced, oxygen is last, hydrogen next to last. I need to balance the hydrogen now. If I put a 3 here, 3 times 2 gives me 6 hydrogens on this side, and that's balanced. To balance the oxygens, I want to have 3 oxygens here, plus 4 there, 7 oxygens, and now everything's balanced. Okay? Alright. Now that we've got a balanced equation, we're ready to do the stoichiometry we have to do. Just like in the last kind of problem we were doing, we start with the amount. We start with the amount of the species whose concentration we know. Read the problem. Study the problem. Interpret the problem. Determine for yourself what amount you have in the problem that you also have a concentration for. Yes? What amount do you also have a concentration for? Matt, read the problem and tell me what species do you have both an amount and concentration for? You don't have the problem written on your own paper?
No, I have the problem written down.
You don't have the problem written
No, I
down?
have it.
Okay. I was just wondering, you were looking up here instead of on your own paper. I wondered.
Trying to think about what you have.
Okay, I'm looking for a chemical species
You got a KO.
for which I have both an amount and concentration for that species.
KOH. Right?
Well, I'm asking Matt.
Could it be HOH?
Well, we're not looking in the chemical formula here. We're looking in the problem itself up here.
Oh.
Read the problem, interpret it, and determine which species in the problem do you have both an amount and concentration for. KOH, I have an amount, 27.45 milliliters, and I have a concentration for KOH. This 2 molar is the concentration. Okay? That's what I want to start with. So I'm going to put 27.45 milliliters of this KOH solution on the top. Okay? As we found out in the third homework problem we had to do last night, or the number 2 problem, since the first problem had 2 parts, Nate, we need to convert this to liters before we can really do anything with it. So what equality statement do I need to convert from milliliters to liters? 1,000 milliliters equals 1 liter. 1,000 milliliters equals 1 liter. Kenya, focus here, please. Okay. This allows me to convert by putting the 1,000 milliliters on the bottom and the 1 liter on the top. Okay. I can cancel milliliters. What we want to do is in order to convert from one species to another, we're going to have to get things into moles. So we're going to use, just like we did with the homework problem, the concentration to get the moles. Okay, so this first part of this problem is just like the homework problem. We're going to use 2.00 moles of KOH over 1 liter of the KOH solution. Okay, that's what molarity is, or molar concentration is. It's moles of solute, which is the KOH, over liters of solution, which is the KOH solution. So we're going to build our concentration unit in a fraction form. This allows me to cancel KOH solution, and I can cancel the liters too, and I now have moles of KOH. Now we're at the point where we have to have a balanced equation.
Hey, can you get back up?
Stoichiometry requires a balanced equation, we said. We need a way of converting from one species
I got a question.
to the other.
On that last part bottom, how did you cancel the KOH solution if you don't have
So right here and here. Yeah, well, you were out the past couple of days. You've been doing this a good bit. They don't have to be right next to each other. It's just in every other, up until now, they always were. Okay? All right. What do you use to convert from one species to another? What? Well, it's a conversion, but what kind of conversion am I looking for here? This is not a conversion unit. This is a different kind of conversion. What do you use to go from one species to another? All right, so what we need then is a molar ratio. The molar ratio comes from the balanced chemical equation. This is why we need a balanced equation. What do I need to put on the bottom here to cancel moles of KOH?
1 mole of KOH. 3 moles.
3 moles of KOH. Okay, since the other thing I'm trying to get to is the phosphoric acid, how many of those do I put on the top? 1 mole of phosphoric acid. Right.
H3PO4.
Correct. Okay. Can I cancel anything now? Yes.
Yeah.
Can this not be on the test tomorrow? We just learned it today. It's like having a test on something the day after we learn it.
You learned stoichiometry in Unit 6. The only thing we're adding that's new to this, is doing the molar part of it. This part of it here in the middle is stuff we've learned before.
But there's new stuff in it, and that just adds on to extra.
You can cancel moles of KOH.
Moles of KOH can cancel. Okay? All right. Now, this will be a little bit different than you used to. This next step, it's not real complex, but it's a little bit different than you used to. We've got, in order to get molarity, remember molarity is the moles of solute over the liters of solution, and we've got the moles of solute for this solution we're looking for. Okay, it's right here. We need to get the liters of solution on the bottom. Okay? the 20 milliliters goes in the bottom. Okay? So 20 milliliters of that H3PO4 solution goes in the bottom. And I just simply put it under 1. Okay? That's how we're going to get them to the bottom. Now, that's not in liters, though. But we've already got our quality statement down here to convert that, right?
You don't put 1 liter on the top?
Well, we're going to have 1,000 milliliters on the top here and 1 liter on the bottom.
Wait, we got 6 of them?
So that then allows us to cancel the milliliters, see? What? Which way? This way? Okay. So we have now arranged so that we've got the moles of solute over the liters of the solution. We just do the math. Okay? So get your calculators out and do the math. So we're looking for molar concentration, which is moles per liter. Okay?
Which is the end line.
Yeah. Yep. That's it.
Molar concentration of what? Case H3PO4?
That's what we have left. That's what we're looking for, yeah. Got it? All right. Let me go through the math here. Pay attention. All right. 27.45 times 2.00. All right. And then we've got 1,000 on the top over here. Going to hit enter. Going to divide by 1,000.
See, I get it when you're doing it, but when I get a test for me, I gotta go under it.
Okay, well, let's talk a little bit in a minute about how I can help you with that, okay? So I want to have the answer down here on the bottom, divided by 1,000. Then we're going to divide that by 3, and divide by that by 20. All right, I get 0.915. And that's moles of the solute, H3PO4, PO4, over liters, that's what I have left, liters down here of the solution, liters of H3PO4 solution, okay? It has 3 significant digits. I don't even have to round off here. However, I can write the answer in a little bit easier form because moles of solute over liters of solution is what, Christopher? All right, so we could say that's 0.915, M with a line under it. That's the molar concentration of H3PO4. Okay?
Yeah, bro.